to start in January 2010. It's actually the first program in the Middle East and Africa, and one of the first 3 programs worldwide to have a very strong industrial application and focus as a master's degree. What we do in research, we look at fully integrated technologies, nanotechnologies. We do, most of our research is material focused. We look at building capabilities in platform technology. Nanotechnology is a platform technology. This means, and I don't have to explain this to an engineer, platform technology is a technology you use to build other technology and other applications on top of it. We have a short-term aim, 2 to 3 years, to demonstrate an actual product out in the market, to convince the Egyptian public and the Egyptian government of the applicability of nanotechnology. And we are looking at practical, strategic, and very business-oriented research. The program will focus, as I said, on fabrication, characterization, nanotechnology, innovation and management, the theory and fundamentals of nanotechnology. We're going to focus on business and management and the public interaction, writing and presentation skill, patent law and license contracting. And then the thesis topics have to be written in one of these areas, which are application of nanotechnology in water, application for oil and gas, renewable energy, construction industry or textiles, entrepreneurship and commercialization. As you can see, the program is very well oriented to meet today's demand in the Egyptian economy. Now, nanotechnology, I'm going to run through this slide very fast. Now, if we imagine that the diameter of Earth, so that just people understand, you're engineers, you know that 10 to the minus 9 is pretty small. But just to capture how small that is, if you put the diameter of Earth, to imagine that it is equal to 1 meter. Now, the diameter of a golf ball is 1 nanometer compared to Earth. This is how small we're talking, right? Now, what is nanotechnology? The emerging definition of nanotechnology, or the most agreed upon, it's not just that you change the size. You can have something that is 100 nanometers or 50 nanometers, and you do not still label it as nanotechnology. The reason is, nanotechnology must be achieving new physical and chemical properties. Not just looking at the size, but actually new chemical and physical properties through changing the size. And I'll give you a simple example, gold. Now, gold is a precious material. We call it noble material as chemists. Noble because it doesn't rust, it doesn't corrode, it doesn't mix with other materials that easily. So it is sort of a nobility metal. Now, if you start doing nanoparticles out of gold, if you reach a certain size, below 10 nanometers, gold, as it is without any additives to it, becomes a catalyst. In the bulk, it is very inert. In nanodimension, it is very reactive. Actually, a lot of industries are using it right now in their chemical processes as a catalyst to lower the temperature of a lot of the reaction. So it's sacrificial material. Gold, which is very expensive, when you start using it in nanotechnology, using it with nanotechnology, it becomes a material that you want to get rid of. You can easily dispense, right? At the same time, gold 55, which is a gold nanoparticle made out of 55 atoms, is more noble than normal gold. So if you have to melt gold, let's say at 600 degrees or 700 degrees, gold made out of 55 atoms, each particle, you need 1,000 degrees. So this is what we mean by changing the chemical and physical properties through changing the size. Now, the other part of it, which is more important, in my opinion, is actually the ability to control where you put this material on the surface. It doesn't have to be a new material. It can be something old, something we have always used. Silicon, we've always used silicon. But the ability to control silicon atom by atom, to place them in a different area, this is nanotechnology. So we have two sides to the word of nanotechnology. The first is that to be able to have new physical and chemical properties due to the change in the size. Not half the previous properties, completely new, something that didn't exist before. The second part is to be able to actually control where to place this material. Right? Now, it is all about fresh and innovative thinking. Why is that? Some of you have heard about DNA-based computing. Now, this is an interaction between biologists, medical sciences, and engineering. This is how actually most science is done right now in nanotechnology. that you have so much interaction that you cannot say, oh, I'm an engineer. I do not need to know about chemistry. No, you do need to know about chemistry. You need to know about physics and biology. You don't have to be a specialist or an expert in chemistry or physics or biology as an engineer, but you need to know and to be able to understand when a biologist stands up and starts to talk, to be able to understand what he's saying, what he's talking about. And how can you, as an engineer, solve the problem he has or come up with a new idea from what he's doing? Now, a lot of people are talking and saying, well, you know what, nanotechnology, fine and dandy, very nice, but it's really science fiction. That is not true. I already showed you some application in the beginning, and what I'm going to show you right now, I want to point to you that in 2007, okay, forget about the investment. The worldwide market for nanomaterials was $148 billion. That is 2 years ago. The actual amount of materials sold to the industry is $148 billion. This is not science fiction. This is happening now. This is happening today. And if we don't catch up fast enough, we're going to be left behind. And my title of the lecture is that nanotechnology is the equalizer effect. And I'm going to describe to you how can we use nanotechnology to be able to catch up to the industrialized world. Now, one very important issue also that there is no regulation limiting the transfer or the use of nanotechnology to any part of the world. And this is something very, very important because, you know, as silicon technology, we have limitation. We cannot fabricate the silicon wafer here in Egypt or anywhere in the Middle East because there's political regulation to stop us from doing that. With nanotechnology, this doesn't exist. Now let us see how nanotechnology started. In 1984, these two guys, Richard Binning, from Zurich, IBM Research Center in Zurich, built a machine, which is this machine called STM, Scanning Tunneling Microscopy. Now, this machine awarded them the Nobel Prize in 1986, and this was the fastest ever awarded Nobel Prize. No one ever had been able to get a Nobel Prize in 3 years since their discovery. This was the fastest ever. And the reason is because the entire scientific community realized what is the importance of this technique. Well, what does this technique do? Very simply, it has a tip that scans on the surface. I'm going to explain in details in a second. And as it scans on the surface, this is a zoom in here, and this is the end of the tip, this is the surface. It passes a current. We're talking here nanoamperes and picoamperes going through between.
اللي انا approved academically. دي الرسالة بالظبط اللي كتبوها.
approved academically.
بالظبط.
ده الاكاديميك اكسبتنس.
وكان الريكومنديشن بتاعتهم ان انا استنى حد يعمل معايا كونتاكت عشان يرتبوا التأشيرة وكده. ومن ساعتها ما سمعتش من اي حاجه، ببعت لهم ايميلات ما بيردوش عليا وانا مش فاهم الموضوع هيوصل لحد فين يعني بقى. هل انا اصبر ولا
لا انا ما اعرفش،
ولا ابدا اشوف
ما
حاجه
اقدرش
ثانيه؟
اديك نصيحه يا باشمهندس يعني للموقف بتاعك بالظبط ايه، لكن بصفه عامه لما حد يقول لي في اكاديميك اكسبتنس، الاكسبتنس جنرال سبيكينج في امريكا في 2 تراكس وال2 تراكس اندبندنت اوف ايتش اذر، وده مهم جدا ان هم يكونوا اندبندنت. اللي هو ايه؟ اللي هو الاكاديميك اكسبتنس وبعدين الفاينانشال سايد اوف ثينجز. معناه ايه؟ انت على مستوى اكاديمي ميت ريكوايرمنتس وفي حاجه هناك اكاديميكلي انترستد فيك. وبالتالي انت اكاديميكلي اكسبتد. السؤال دلوقتي مين اللي هيسبورت يو فاينانشال؟
في سكولرشيب انا بقدم عليها مش مقدم.
اوكي يبقى خلاص يبقى بس انت منه مش كلمه اكاديميك اكسبتد، يبقى هو يبقى كده انا مش شايف مشكله، مش عارف بقى تطلع ايه المشكله. لو انت بتقول انت اكاديميك اكسبتد وفي نفس الوقت عندك فاينانشال
سبورت على سكولرشيب بالظبط.
مش معنى لما اقول لك انت اكاديميك يو ار اوكي، مش معنى ان انت كده خدت السكولرشيب. انا بقول لك انت عديت مرحله بس ما وصلتش مرحله ان انت خدت السكولرشيب، مش شرط. اقول لك انت قبلت السكولرشيب
لازم يكون فيري اكسبلسيت يعني صراحه.
يعني لازم كلمه سكولرشيب دي تطلع في الاكسبتنس ليتر بتاعهم ولا ايه بالظبط؟
ممكن تكون سيبريت ليتر، لكن ممكن تكون لكن لازم تكون صراحه ما فيهاش اي غموض ان انت فاينانشلي جت فاينانشال سبورت.
يعني عشان برضه دي قصه حصلت واحد زيي برضه نفس القصه، ان هو قدم على الجامعه برضه قالوا له انت فاين بتميت الريكوايرمنتس بتاعت الجامعه.
Molecule or an atom on the surface. Some of you have seen the image of IBM, the word IBM written with atoms. Did you see this image? IBM